Dear participants of the conference, let me introduce the report on the item Features of Using Frameworks and Artificial Intelligence Language Models for JavaScript Code Optimization in Web Application Development. All authors of this work represent the Department of Information Systems and Technologies of the Poltava State Agrarian University. The evolution of web development technologies, the variety of tasks, and the growing requirements for performance, security, and scalability of web applications have led to a significant diversification of the developer's toolset, as well as the emergence of tools of specialization and simplification of the creation of individual projects. New languages are often developed to make specific tasks easier or provide more user-friendly tools for certain types of projects. Various companies, organizations, and developers are experimenting with new approaches to web application development. This promotes competition and the drive to create a better programming language or framework that meets specific requirements. However, along with the evolution and the diversification of technologies, with the rapid growth of the number of web applications, new problems have appeared that were not so obvious before. For example, ways to achieve unification, rationalization, and optimization of the code. Frameworks can be considered as a set of tools, standards, and approaches to writing code that are able to solve the mentioned problems. Gradually, the number of solutions, such as frameworks, has increased significantly. There is a joke that if you open an English dictionary and select any word, there will already be a JavaScript framework with that name. Over time, it becomes clear that there is a limit of the capabilities of each of these applications, and quantity does not always translate into quality. Further expansion of the framework's functionality is expected to include artificial intelligence integration. The purpose of this work is to explore several conceptually different means of achieving optimal results in creation code for web development, such as different JavaScript frameworks, as well as the capabilities of artificial intelligence language models trained on different programming language libraries. In modern software engineering and information technology, research on the criteria of selection frameworks is relevant, as it contributes to the efficient use of resources and achieving high software quality. State of art in our work developed to the review of recent research included in analysis of work that investigated the performance effectiveness of different frameworks for different programming languages. Brief results of the studies are given in the tables on slides 4 and 5. As you can see, different systematically resorted different frameworks using different methods for different web programming languages. The general conclusion was that each framework has its own characteristics, advantages and disadvantages. The popularity rating of many well-known frameworks does not always correlate with the actual results of their technical capabilities. Our work presents the results of own research into JavaScript frameworks to conduct the performance study of the Angular, React, Svelte, and Vue.js frameworks. Two different tests were carried out under high and low load conditions. The purpose was to evaluate the performance of front-end frameworks with the result measured using built-in functions. The first test results are presented in Table 1. We indicated versions of frameworks, Angular, React, Svelte, Vue.js. All numerical values are given in milliseconds. The best result in each test is highlighted in green, while the worst is highlighted in red. The measurement results varied somewhat. Angular and React showed the worst result in almost all tests, with which some exceptions. React performed best in clearing rows, and Angular excelled in selecting rows and partial text updates. This may be due to the slow performance with Virtual DOM. Vue.js and Svelte had the best indicators, with Vue.js being faster in more tests, but Svelte was not the worst in any of them. Overall, Vue.js provided to be the best, while React was the worst. For the second test, four simple, functionality identical test applications were created using each of the previously discussed frameworks. Measurements in this test were conducted using Chrome DevTools. The study was conducted using the same workstation and software as in previous test. The following Chrome DevTools metrics were considered during the research: system operations, scripting, JavaScript code execution, rendering, page formation in memory, painting, page display. The functionality of created test applications included the following functions: creating and displaying 1000 random text rows. During this operation, the framework cannot use pre-created elements. Therefore, this operation is the most resource intensive. Removing all rows. This operation removes all previously created elements from the screen and application memory, changing one random row to another. During testing, each function was executed 20 times. Next table shows data about the total duration of the operations in different frameworks. As you may see in the second test, the frameworks showed almost identical overall results, but results for individual criteria varied significantly. In particular, React performed poorly in sprinting, but outperformed all others in system. This indicates significant differences in the architecture of frameworks. The good result for Svelte is due to the fact that it does not use Virtual DOM, unlike the other frameworks, and complies directly in the low-level code. The analysis of the effectiveness of various frameworks for different programming languages supports the view that these tools have limitations and lack universal options. The search of optimal solutions for different tasks is ongoing. The metrics in this work were selected to extend existing research and assess the time-based performance of different artificial intelligence models in the future. Today, more and more tasks of data analysis and performance of routine operations are being tried to be transferred to artificial intelligence, which is not only experiencing a second wave of popularity, but also demonstrates significant productivity accuracy. The element described in this work was conducted with the primary goal of exploring the capabilities of popular LLMs and testing the hypothesis about the potential of recognizing, correcting, and optimizing source code, as well as the possibility of creating entirely original code with specified parameters as an output of artificial intelligence. For the experiment, a JavaScript file from a functioning completed website was used. The file contained 148 lines, including comments regarding the purpose of individual functions and data processing methods. A snippet of the code is presented in Figure 1. Three main large language model LLM were used: GPT-4o, Gemini, Codestral. The code was loaded directly in the chat and analysis through a dialogue, during which a prepared list of questions was used. The questions are given on the slide. The formation of prompts for each LLM was strictly identical. Next slide shows how the model describes itself. GPT-4o is a lightweight version of GPT-4 that balances between text processing quality and hardware resource requirements, making it suitable for local deployment and offline applications. As you know, at the moment you can already use a more advanced O1 preview model. The next slide shows a fragment of GPT-4o's answer the second question, namely, can this code be optimized without losing functionality? The artificial intelligence generated changes improve code readability, maintainability, and slightly improve performance by reducing code duplication and making better use of built-in methods. Thus, the responses provided a precise analysis of the code, both the original and generated, and an improved version of the code with changes such as removing unnecessary checks and operations, combining similar operations into functions, and eliminating code duplication. To expand the scope of experiment, a similar study was conducted with Gemini by Google, which can be considered a counterpart to Criterion of GPT-4o. The dialogue was conducted in the same way as in the previous variant. However, when increasing with Gemini, interaction with Gemini, code generation was not achieved, and everything was reduced to generalized statements. Considering the growing interest in local versions of LLMs, similar studies were conducted with Codestral 2022b version 0.1 GGUF. Unlike the previously considered variants, this approach was several advantages due to several factors: data confidentiality, low latency, and high availability, customization and adaptation for specific tasks, economic efficiency, independence from external services, support for local languages, and peculiarities. The LM Studio platform was used for this purpose. In this open source tool that optimizes the process of training, evaluation, and using modern languages models locally. Given the release of the latest version of LMS LLama 3.1, it is expected that specialized versions for working with code will be developed. Consequently, future research should focus on utilizing this open source LLMs variant. This work presents the results of using several LLMs, including open source options with localization capabilities for optimizing code after it's generated by developers within a framework. Future research could focus on new versions of open source LLMs, as well as specialized platforms designed for generating code in other programming languages. Summarizing the results of the conducted research on finding possible ways of technical optimization of the software code during the creation and use of JavaScript-based web applications, the following conclusions can be formulated. The analysis of the futures of frameworks Angular, React, Svelte, and Vue.js indicated the using different frameworks yields predictably higher results in code writing in the programmer's experience, allows them to assemble a kind of puzzle where the tasks and chosen technologies are legion. It is anticipated that the future expansion of framework functionality will involve integrating artificial intelligence. The results from the investigated large language model demonstrate their ability to accurately recognize the JavaScript code, understand the functional aspects, and provide suggestions for optimizing and rationalizing code without losing functionality. All models operated by loading the examined code directly into the chat. Gemini provided the most extensive recommendations for improvement, while GPT-4o offered quick new code generation. The report is finished. Thank you for your attention.
Thank you very much, Elena. Who has a question, please? Go ahead, Daria.
Yes, thank you, Elena, for your presentation. Do you know maybe some frameworks or tools which combine AI and JavaScript optimization in web development, or do you need to use special AI models?
We did not use. Thank you for your question. We did not use these such frameworks as I understand. Such models were presented in the first report in our section, but the history of our work was begin from needs to compare some frameworks for different languages, and that was an idea for my students who discussed sometimes what is the better, and the idea to use the artificial intelligence was begin in the process of comparison of different frameworks, and now we will ask the new tools which involve in the artificial intelligence also, and we will our future work must be devoted to writing to generation code in artificial intelligence environment. But architect to combine of this we don't use now.
Okay, thank you.
Who has additional question, please? Okay, no question. Thank you very much, Elena.
Thank you.
For your report. Thank you very much, Daria, for your question.